Right, guys, we are now on to the next concept, which was in session 3, but I've actually put it into its own session because it's quite just a concept I want to separate out. Anyway, so here we go. So basically, here we are. We're going to revisit this timer block. We're going to the timer circuit, and then we're going to make a function block out of it, and then we're going to talk about the safe start concept, which we'll get to now. Right, timer block. Okay, so we're going to go back to our OB1 in the PLC. We're going to look at that timer that we created, that timer circuit, which was there. We're going to create a function block out of that, so we can then put inputs and outputs on the function block and parameterize it, and we can see if it still works the same. So I'm going to start Siemens step 7. Right, so here we are on our project. If our test project, so if we go to OB1, where we were before, remember here is our timer. This, remember, was a timer that we created out of a comparator and a 1-second pulse coming from the clock. Do you remember where that comes from? The clock pulse, and it adds 1 every second. And if that bit is on, which is the trigger for the timer, it starts to count up. And if that bit is off, it resets the actual to 0. And once the timer has reached, the actual has reached the preset greater than or equal to, it then creates a state and output that says the timer is completed. So I have already in OB1 created a timer function block, and there's nothing in it. So I'm going to literally, sorry, I want to go back to this. Go back to OB1, and I'm going to copy this network and this network. I'm just going to copy it, Control C, go back to my function block, and I'm going to press Control V. I'm going to take that one out, and I'm going to now what do I have to do? I want to not have these things. I want to have this as an input, and this is an input, or this is an input. So I want to parameterize this block. Okay, so I'm going to just drag this down. This is now the interface to the block. So here's the first one. This is now the trigger for the timer. So I'm going to go to the in part here, and I'm going to make a tag called TIN for timer in. That's going to be whatever condition has been put in the front here to trigger the timer. So that's the timer input. Okay, so now I can literally take this one out, and I'm going to make it TIN. You see it's put a little hash in front of it. That's just telling you that that is a parameter or part of this parameterized block. So now the next one is this preset and actual. Now, one thing which we'll get to see is that the preset is an input. The actual is actually an input and an output, because next scan has got to come and get the previous value of actual, and then see if it can add 1 to it. If you don't do that, it will never add. So I'm now going to change the preset here. I'm going to make that an input. So I'm going to call that TP, and it's an integer, and it's going to be timer preset. And then I'm going to use in the in-out, I'm going to call the TA, it's also an int, and this is the timer actual, the actual value of the timer as it's counting. So now all the TX, I'm going to make that TA, and all the presets, I'm going to make TP, that's a TA, that's a TA, TA, and that's TA, and TP. Now we've got this last bit, which is the output. So this is only an output. So we're going to go to the out here, and we're going to make a Q. That's the common tag for Q, and that's for an output, timer output. Oops, output. And I'll change that to Q. Now I have actually, this is the timer output. Oh, I can't type. And this says the timer elapsed. Oops, elapsed. All right, so now I've created my function block. I'll just move that across. I save it. it's going to give us a prompt. We have changed the interface, so it warns you that if you've got this block in your program all over and you change the interface, you have to go everywhere and change it. So one has to be just a little bit careful what you do to change it. This is the first time we've done it. So there's our timer block. So I'm literally going to close it. I'm now going to just take all of this out, and I'm going to take that out as well. I'm going to literally put my new timer block in here. So I'm going to go to this little part here. I'm going to press FC2. Remember, that was my timer. Let me go back. FC2 is timer. Siemens has put the timer there. Now you see it's created those parameters, the in. So this tag has actually go here. So I'm going to put this M50. I'm going to put there. I'm going to put this tag over there, so I can delete that. I'm going to delete that. Now I've lost that thing there. So I made a little bit of blups. I'm just going to go to my. So the moment I start typing here, it starts to search in the tag list all of the things we had. So I remember it was under parameters. So there is the start time. Well, I can even go here, timer 1. So I want the preset. And this one I want to also go to timer. So if I go see default straight there, it's timer 1 and the actual. And now there is my timer function block call. So if I save this, I can now literally go and load this into the simulator. Okay, so let's see if our program is running. There we go. So now I've highlighted this block. There's my timer. If I go now set this input bit, remember we had it as a 1, and there we are. Our timer is starting to count. We don't have to worry about anything else. We'll just wait for this to count to 10, and our output should come on. There it is. Okay, so our timer works. Let's literally go use a feature of this PLC. I'm going to go to debug operation. I'm going to put on test. It is on. Normally isn't on. So now if I go and just download this program again, you always have to download it again. But if I now right click and go open call block, and I can call it up with what they call the call up path, it will then use this instance of the call. So now I'm literally live in that block for that one call. So if I literally go back to this marker and I put it and I put on monitor and I put on modify, I go back to the window, you can actually see there's the block. Literally as we had it before, there it is going. And that is how you make a function block. So now that timer block, FC2, I can use it as many times as I want. So there we've parameterized the timer block. And now we can go and, so we've done all this. We changed the timer block to a function timer to a function block, added the inputs and parameterized it, and then we've called it, and that's how we parameterize the timer. So we can then call as many as we want. Okay, here is now the concept of safe start, and this concept comes from mining. What it technically is where you have a mining operation which has long conveyors, and you might have some chutes and some conveyors coming up from underground, and they go into silos, and you've got feeders underneath. What will happen is when they want to start the plant, they have lots of labor and lots of people running around the plant, and they need to warn them that something is going to start. So what happens is, say at the one silo, they will then have a siren that some motor in that area is going to start, and everybody must now be careful what they're doing. They must take all their hands out the machines and wait to see what starts. And the siren will go, it can go for a long time, and then something will start up, and then they can continue. But now they know that something is active. This now comes back to another issue. it's called a safe start concept, because if somebody is working on a particular motor or device, they need to use the safe lockup procedure so that they will know that even if the siren goes off, that motor they're working on will not start. And they have to themselves personally lock it, and there must be procedure so that they cannot be hurt, they cannot die. And okay, well, I could talk for hours about that. But how long does it take to start up? Well, that's the issue. Some plants, you might have a lot of motors, a lot of groups, and so you want to put the siren on, and you have a certain time delay, which they call a safe start period. Say it's a minute, and motors start to start, and then that minute has elapsed, and something else has to start because the sequence is continuing. So what they need to do then is to put the siren on again to re-warn people that something is going to start, and then the safe start period starts again. So it looks like this. So what would happen is the operator would start the sequence or plant. He would then start it. The siren would sound for 10 seconds or a minute, depending on the plant and the area. And then there would be what they call a safe start period. And during this time, motors would start. Motor 1, motor 2, motor 3. When that time has elapsed, the siren has to be put on again, and then motors can continue to start until as many cycles of that is required until the plant is started. So that is what we will then do. So we need now 2 timers here, one for the siren and one for the safe start period, and they will work together so they can start each other. All right. So one concept which we're going to add to this, remember we spoke about groups and the navigation buttons. We're going to make a functionality that if something in the area has got a fault, they can press a reset button, or they can right click on the button, and it will reset all the faults in that group. So we will add an alarm reset feature to our group. And now if there's a couple of faults, if you reset the motor fault, it would then allow you to reset the flap switch fault, and then you'll be able to reset the next one. So an alarm reset has a couple of seconds to cascade reset all the faults. And yes, they can click the button umpteen times, but generally a couple of seconds for a reset timer is useful. And then, as we know, in a lot of plants, they have e-stops. They have e-stop buttons all around, and in mining they have what they call a pull wire system. So they, on the conveyor, if somebody is stuck in the conveyor, anywhere along the conveyor, they have a wire which, if they pull it, it will then cause the conveyor to stop. And so all of those e-stops and pull wires are normally wired in series into one input in the PLC, which, if it's true, we must remember fail safe. If it's true, then it's healthy to run. And if the power goes off, or if somebody pulls a pull wire, pushes a button, all the equipment in that area must stop. So we've added to our group an alarm reset feature and a timer, and then a common e-stop. So we're going to create a UDT out of that. So here we're now going to create a UDT. Remember what a UDT was? It's a user-defined type. So we will add into our user-defined type an e-stop, bit or boolean, a reset button or reset function. We will then have what we call the safe start period active, and we will have a safe start request. So what happens is, if we've got 5 motors in the group, any one of them starting will create a safe start request. It will say when we want to start, and it will then activate the siren, and then the siren will activate the safe start period. Then the safe start siren, SS siren, will then, so those are the tags to work that functionality. Remember before we spoke about a warning functionality and alarm. This is just a spare bit. If you do this in the Siemens, if you don't put that bit in, it's fine, but when you want to do it and change it, you now have to remember you've changed the UDT, and it changes everywhere, and it can cause problems. Then we have the group run and stop that we had before, some spare bits. These are the outputs of those timers, the reset timer, the siren timer, and the safe start period timer to work with with those bits. And here is the actual 3 timers, the preset and the actual for the reset functionality, the preset and the actual for the siren functionality, and the preset and the actual for the safe start period. So, and you'll see now why I've got those extra ones. If I now flip to the PLC, I'm going to show you what the UDT would look like. If I go back into this, I'll copy the UDT in here. So there it is. This is the UDT, and Siemens has already addressed it in the bits and bytes. So that GLB07 is byte 0, bit 7. These are byte 1, bit 2, 3, and 4. So everything is nicely aligned. There's byte 0 and byte 1. And then we have from byte 2, that's an integer, so it takes 2 bytes. Preset, actual, preset, actual. And you see, if I ended it there, it would end at 12. So if I put it into a data block, the second one would start at byte 12, which is fine, but then the third one will start at 24, the next one will start at 36. It's easy when it's a round number. Imagine if it was 13. You can't remember what the 50th 13 is. So I always suggest that you put in some filler words or bytes in here that you can round it off, that it's now got a round number, it's 20 bytes, and it makes it easy and functional. So if I flip back here, I'm now going to create my new DB, and you can see here, I've numbered it as UDT100. So I'm going to create a DB, insert a new data block, and I'm going to call it DB100. And this is going to be, see it says UDT global flags. I'm going to, okay, so I'm just going to say, okay, I'm going to change this so that it makes, oh, I can't change it because it's open. Let's close it there. Let's close that. Let's go back here. I'm going to change this, and I call it going to be UDT for groups. Okay, just so we use the new naming. So now my DB100, I'm going to now rename that. You right click, you saw I did it with function key. You can press Alt Enter, Alt Return, or you can do that. I'm going to call that the DB for groups. Right, so if I now open this DB, Siemens has just put a temporary placeholder. So if I put in here area 1, and I then call UDT 100, I don't want any number there, and that's area 1. You see now what it's done? It's actually created all those bits in there, and see it's got 20, because that UDT is 20 bytes long. So if I go area 2, and I can even go up there and Control C and Control V. I'll just do a few more, area 52. Come on. Oh, I can't put a space, that's right. V and area 52. Now you see it's all nice and neat. It's all in 20s. If I now you can see it's now got a structure. But if I now go to view here, it's showing you it's in declaration view, which means you can see the structures. If I put it into data view, you can actually see each of the independent bits and bytes in that structure. So you can see it's got the prefix area 1 dot e-stop and area reset, etc., and on. And there starts area 2 for 20, and there's area 52. So I can then go back to view, change it to declaration, and I can save it, and I can download it. I'm going to go and create a new function here, and I'm going to call it FC100, and it's going to be called group safe start. I'll do that, so we can go in here now. So now, what we have to input in this block, we have to do some logic with that UDT. So I'm going to just do I'm going to just hide that one, and then I'm going to do a nice little Okay, so there is my UDT, and I'm going to make that an in-out over here. I'm going to call it group and call UDT 100. So now I've got that whole UDT input into the block. And there it is. There is the features that are literally there in the UDT. So now I can go and program my function block to do the safe start. So the first thing I want to do is I want to take my e-stop system, my e-stop. I'm going to go back to my DB1. Remember, we put a global e-stop in here. There it is. So it's DB1 or db.global.estop or just DB1 e-stop. So I'll just delete that. So I just type db1.estop. There's my e-stop, and I need to put it into that bit over there. So I need to put it into my group.estop. So if I just type group.estop, I've now put the e-stop, the global e-stop, into this safe starts e-stop bit. Right, that's the emergency stop. Put in. So now I'm going to create another rung, and I'll make this the reset timer. Just okay, emergency stop, so it's nice and documented. So now I want to now make a reset timer. So now I have to put in block. I normally just use that. It's FC2. I know it. And now I'm going to put the reset of this as the input into this. And the preset is now going to be RTP. So it's grp.rtp, reset timer preset. And the actual is group reset timer actual. And the output is going to be reset timer output. There it is, RTQ. RTQ. No, it's going to be group.rtq. Right, there's my reset timer. Now, what must the reset timer do? It must reset that reset bit. So, next rung, take that. We can copy and I do that. I don't want to do that. I want to make it a reset bit. So here's a reset bit, and I want to reset that. You see, I use copy and paste a lot. It's just quicker than typing. Sometimes it's quicker to type, but sometimes it's easier. Right, so now remember what we said, that is functionality you build into the SCADA that on area 1, so you will have a button which says reset all the faults. That will put this bit on in this UDT, in this DB. It will then time out for the time, which is 5 seconds there, you can see. And then at the end, it will reset the same bit. So what that allows you to do, let's say you have interlocks which are also latched as a fault. The first scan or the second scan the first scan will reset the fault of the latched interlock, and then the second scan will reset the latched fault of something else, and so on until it resets all the faults, the cascade of faults, and then the reset function can reset itself, and we'll have our plant back to a normal state, and we can try and start it again. Okay, so now we want to do, the next part is, let me go to, we've done the reset timer, we want to do the safe start request. Okay, let's just put in safe start timer here, a safe start request, or safe start siren I'm going to put here. Okay, so we have here a safe start request bit. That will be a combination of all the motors in this group which have been requested to start and are not currently running must activate the siren. So we're going to put in our group.safestart request, and we're going to make that put on the siren. So group.siren, we'll call it SS siren. Okay, safe start siren. Now that will be wired. There will be logic that will put that to a physical output, which will sound the siren. Okay, so now anytime there's a motor that has got a start request and not running, it will put the siren on. It's going to go it's going to carry on sounding forever, but we're going to fix that now. Right, so now we've got our siren on. We now need to make the siren timer. So I go and do that. Our timer, FC2. That is my input into the block. And now I need the second one here, the siren timer. Siren preset, so that's STP, group.stp, group.sta, and this one will be the output, which is going to be, sorry, that's not working so well, siren output, timer siren, so it's STQ, right, so, no, group.stq, right, so now I have the output of the siren timer. Now what must happen after when the siren is finished sounding for 10 seconds? We want it to now activate the safe start period. So safe start period is going to be 20 seconds in this case. So when this timer times out, we want it to now set our safe start bit here, group safe start. So that is now telling the other logic that we have now siren and it's safe to start. We're going to now put this bit in here to put the siren off. So now the safe start request is technically still on. We put the siren output on. After the time, it's now put latch that. So now, even though the request is still on, the siren will go off. Thank God. You know what will happen if you don't do that? If you keep the siren going, operators will find that siren somewhere in the plant and they'll break the wires. They'll break it, or they'll stuff paper and socks in it, and then there will be no siren. And then you have the problem that that somebody could get killed or somebody could get hurt, and it's because your logic hasn't put the siren off. So it's just a nuisance. Okay, so a little forethought there. Okay, so now we want to create the actual safe start timer, which is this 20 seconds. So once again, we put in our timer. This is our time, and it's going to be group SSTP there, group.SSTP, group.SSTA, and our output is this SSTQ, so group.SSTQ. Right, so now that is the save start period timer. Oh, I can't write, can't. Okay, so now what must happen at the end of that? It must reset this bit. So once again, the output of the timer, and we wanted to, we actually don't want an output, we wanted to reset this bit. Okay, so there we have it. So what will happen is that will reset this bit. So if the motors haven't started, this bit will technically be still on, and it will sound the siren again, and it will go carry on. It will go back and do exactly what we've shown in this timing chart. Siren will get the start request. Siren sounds, then the safe start period. If it hasn't finished starting all the motors, put the siren on again, and there's the safe start period, and on ad infinitum until all the motors have been started. Okay, so let's go in. So now I can literally, I'm going to keep that open. I'm going to now save, and I'm going to, oops, interface change, that's correct. I'm going to download my block here. And right, so now, although I've created the function, I haven't called it. So I need to go back to OB1, and I can just maximize this quickly. I'll just minimize that. I can leave all that. Well, this was just temporary. What we're going to do now, let's leave it, go down to the bottom, and now I'm going to call that function block. So again, it's a function block, so FC100. Now, what is the input here? The input is actually, in my DB, input is area 1's UDT. So I want to put that in as the input here. So the moment I start typing, Siemens prompts you with anything that starts with what you started typing with, and there's DB groups, and I'm going to highlight area, and there is the input into the block. It looks a bit different if I go to statement list and go back. This is ladder, as you can see. If I go to view and to statement list, you see there's some function keys or shortcuts. It's Control 2. I can do statement list. You can see there's the function and there's the input into the function, and it puts this little no op in there. And that is the little trick that Siemens does. So if you take that no op, you cannot go back to ladder. So if I go Control 1 now, you see, although it's converted all those to ladder, this one isn't converted to ladder. So I'll put the no op 0 back in, and I'll do just Control 2, Control 1, it's back. Just remember that. That is a real nasty one that Siemens has got. And this is what all the fancy, clever people of Siemens tell you. If you take that out, you save one instruction. So if you do all your stuff very clever, all in statement list, it's nice and neat. There's another no up there. I say we have so much memory, we have so much functionality now. We don't need to all be writing statement list. We'll have a whole discussion later about how statement list is very hard to debug. But to me, ladder is most graphical and simple. It combines the wiring diagram that you would have had with a positive bar and the contacts and a coil with what logic does. So I think it's one of the best and what most people understand. Okay, that's the end of what I talk about this. Right, so I'm going to call this block. And right, I'm now calling my block, and I'm going to now monitor it. And if I go in here, there is my block being called. So I want to just, okay, so now we're calling the block and nothing's happening. We don't even have an e-stop. So I'm now going to go and create a VAT table. Go back to there. Why can I not get back there? All right, so I'm going to create a new VAT table. We've got all these other ones. No problem. Create a VAT table. Right, I'm going to open it up. Now I'm going to just rearrange the screen quickly so that I can see both things. So if I literally do that and then go to my bar here and show side by side, there we have our fancy stuff. If I just go back, go to my UDT, I can see, okay, that I have, if you look at the UDT, it has got 16 bits, byte 0 and 1. So literally in my VAT table, I could type here, I know it's DB100, remember it's DB100. So I could type in here DB100, oh, why am I clicking? Type in here DB100.dbx 0.0, and then I can do the next one, 0.1. So let me type one more. And you see, I can literally go one for one, but that's a pain. And so we'll just delete that quickly, and we'll use the feature that's in the VAT table to insert a range of variables. Okay, so now you can see if I start at 0.0, dbx 0.0, and I put in 16 booleans, I'm going to get all of those 16 bits in one go. Bang. I don't have to type them in one by one and save myself a lot of grief. So now I want to also put in these. There's 1, 2, 3, 4, 5, 6. So I'm going to start at 2. So I go back to insert, start here, I go to dbw2, and I want 6. Oops, 6, and I want it to be decimal. There we go. I have my VAT table. I can even save it. If I go to monitor, there we have all our values. So now I can literally go back to my function block, and I'm monitoring still. Am I monitoring? No, I'm monitoring. All right, so this first one, the e-stop, I'm going to just See if I can modify that to 1. I can. So the e-stop has been copied to the e-stop, and you can see there it's in the UDT. It's in my DB. It's now saying everything's safe. So now let me show you what happens if I do the reset. So I'm going to make as if the SCADA we've clicked on the button, and we're going to make this true. And from the VAT table, I can make it true. See, there it's true. It's now counting. At the moment it goes true, it's going to put it off. And now the bit has gone off. You see that? So that is now done the feature of the reset timer. Okay, so reset timer works. All right, so now we're going to make as if there's a start request. We're going to do that logic just now, where on a further exercise, where we're going to put on the safe start request. That means that any motor in this area has got a start request and it's not running yet. It will put the safe start request bit on for us, and then it will start to activate these 2 sets of timers and counters. So we're going to watch it down here, because Siemens is just only giving us, it only gives you a certain view, and then the rest is not view. So you've got to go and click there to see the rest. A little bit of a pain, but so we put it in VAT table. That's another power of VAT tables. I'm just going to delete that one, and I'm going to go to my safe start request. I'm going to activate a safe start request. And what do we expect to happen? We want the siren to come on and time out for 10 seconds, and then it should put on the safe start period, and that should time out for 20 seconds, and then it should reset and it should start again. It should put the siren on again. So we can watch these timers counting, and we can watch the siren going. So I'm going to do that on my VAT table. There's my safe start request. The siren is going. Wow, 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 wow. There's the timer. It's counting. Siren's still going. Wow, 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 wow. Siren's gone off, and now the safe start period is on. We can see it over here, and our safe start period is counting, and that first motor would have started, second motor would have started, the third motor would have started, fourth motor would have started, and now we've got a time delay, and now, oh, we're going to start another motor. So the safe start puts the siren on again, and it goes wow, 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 wow for 10 seconds, and then after 10 seconds, you can see the safe start now is on again, and it counts on and on and on until everything has started. And that just begs a little question. What you want to do is, in your logic, if the sequence hasn't completed within, say, 5 minutes or 10 minutes, you reset the sequence and you say, okay, there's a problem, and you then at least stop the siren going on forever. So if I put the start request off as if everything has started, the safe start will time out the last time, and then it will stop. And then basically the 20 seconds will end, and the safe start will go off for the last time. And there we have our safe start. That is now got our 3 functions. Let's go back. We have created we put the e-stop into the block. I will show you in the future when we create the function blocks for the drives and the valves and the digital outputs and the digital inputs, that e-stop will be in all of those blocks. We're going to pass this whole UDT into all of the blocks that are in this area. We're going to put db100.area1 into all of those blocks. All right, so we've created the reset timer. We triggered the safe start request, which puts the siren on. Siren timer triggers, and that triggers the safe start period, and it goes backwards and forwards, on and on. Okay, so there is our safe start. What we have done, remember, I'm going to just go back. We have created this feature that allows us to do that. And so the homework, oh, there is homework. In your plant that you had split into, can you identify if you go to the plants that you see, can you identify all the motors and valves and devices that could indicate a warning or fault that could occur, what faults could happen? and how you know if the area is running or stopped. How do you know? And the other thing, just as an added feature, is think about how you would put into our navigation bar. Remember, the title bar on the right-hand side, we want to put a symbol of a siren, and we want the siren to be red when the siren is sounding, and then we want the symbol to be green during the safe stop period. And if it's not doing that, it must not be there. It must not be visible. So it must be only visible when it's either the siren is sounding or it's in the safe stop period. That's your little test for today. And that really is what the safe start concept is.